Ngalakin Khadijan Nyunga Boja.
Video 8, the Data Definition Language, or DDL. So traditionally, SQL commands are divided into groups according to their purpose. DDL stands for Data Definition Language, and those are the commands that are used to define the structure of the database when it is first created. So the database designer will talk with the users to determine their requirements, and then will decide how best to represent that in the database. And then once off, the database will be created. So the tables will be given names, the columns or attributes will be given names, their types will be chosen, the data types will be chosen, and a variety of other more advanced properties that sort of live throughout the existence of the database table. Then the database is actually used, and while it's used, data is entered and changed and queried and deleted. In fact, all of the 4 CRUD operations, create, read, update, and delete. So the creation of the database is sort of a once-off operation. You just do it at the beginning. And then the use of the database is ongoing. So people will use the database for as long as it's needed. Obviously, therefore, it's very important to get the important properties right at the beginning of the life of the database. So to design it properly is important. What we're going to look at today is really just the mechanics of defining the tables and the attributes for a new database. Okay, so let me just remind you of how the general scenario. So when we're using SQLite, I was using it from the command line window. My prompt on my machine happens to be the name of the user and then the directory in which the user is currently located. So this shows me that I'm in directory lab2. Then I ran SQLite 3. So that is a Mac command that says start the SQLite process running. Once the SQLite process is running, it then starts to listen out for any more commands by the user. So it produces that little prompt, the SQLite prompt. At the SQLite prompt, I can do either dot commands, which are SQLite specific things, or I can enter SQL commands, which are regular SQL commands, which may be queries or something, and the SQLite program will respond to me with the results of that query. If there's no output, then the SQLite program just produces another prompt and waits for more information. So no output doesn't necessarily mean there's any problems. It just means that there was nothing to say after that particular command. So what I want to look at in particular is this command. So .schema city says, show me the structure or the schema of the table city. Now, the way SQLite does that is it actually returns to you the command that was used to create that table in the first place. So when I look at what command was used to create the table, then I see a special SQL keyword, create table, or 2 keywords, then the name of the table, and here it's called city enclosed in backticks. And then there are some information about each of the fields. The first field is called id, and its type is integer. Then there's a whole pile of additional sort of strange stuff that we don't know about yet. So just ignore that for the time being. There's no, those keywords alter the way that field behaves, but we'll explain what they do later. Then there's a name, which is char35, and I'll explain that in the next lecture. Then there's a country code, What this actually means, char 35, it means a data type that allows you to store 35 characters. So the name of a city is, I guess they're saying it's forced to be at most 35 characters long. Then country code is the code for the country. That's always a 3-character code. So like AUS is for Australia, AUT for Austria, and so on. And then there's population, which is an integer. Okay, why do all of these names have the little backticks on them? So instead of saying id with the 2 backticks, could I just say id without them? And the answer is yes, we usually do it this way. So it's usually done like this, but SQL is particularly cautious, and it doesn't know whether you might want to have columns with names that have spaces in them. So if your column was going to be called first name, for example, well, then you couldn't call it first name if you called it first space name, because it wouldn't know where it would imagine that the word first was the name of the column, and then it would say, well, what the heck is name doing? So the backticks are just there to be delimiters. They just say where the name of this column starts and where the name of this column ends, and then you can put spaces into the column names if you want to. I would just advise don't put spaces into variable names, and then you can leave off the quotes and it's a lot easier to type. Okay, so let me go through the various DDL commands, the data definition language commands. Okay, create table is the fundamental command. That will create a new table according to the description that you specify, and when it's first created, it will have no data in it, so it will have no rows. It'll be a new empty table. If you have decided that you don't want a table, it's superfluous, it's sitting in the database but not being used, then you can issue the command drop table. So drop table, and then just the name of the table that you want to drop. Drop table city, semicolon, because it's a SQL command. That will just delete the table city and all of its data. All of the rows will be gone, all of the other, all of the schema will be gone as well. The other thing you might want to do is alter a table. You've created a table, maybe you've put some data in it already, and now you've decided that it's not exactly how you want it. So alter table can be used for 2 main purposes. You can either rename a table, rename the whole table, or you can rename just a column, or you can add a new column to the table. SQLite doesn't really implement all of the specified standard functionality of alter table. Other versions of SQL will allow you to delete individual columns, shuffle the columns around, and a variety of other sort of table alterations. Okay, SQLite is sort of a very lean program, so it's sort of just basically keeping the just enough functionality to be useful. Right, so before we start talking about the data definition language and the things you might be able to do with it, I just want to talk about a little database that we're going to use sort of throughout the semester. It's going to store student marks, and it's going to have the following requirements. So a student has a name, well, that's pretty clear, and a unique student number. Okay, so that phrase is telling me that student number is going to be something that has to be stored in the database, and that it is going to be a key field. So it's going to be a key. You can't have 2 rows referring to the same, you can't have 2 rows, in other words, 2 students with the same student number. So that's a requirement that arises from the business logic of how universities work. And we want to build that into the database so that that requirement is enforced by the database. Okay, a unit has a name and a unit code, a unique unit code. So that's told me about a key again. It's telling me that unit code is a, whoops, I didn't want to draw that. I wanted to draw that. So that's a key as well, but that's a key for the unit table. Students enroll in units in a particular year, and then they get a mark, and the mark is any number between 0 and 100, and the pass mark is 50. And if a student wants to, they can take a unit again. For example, they might fail it in one year and wish to retake it to pass it in a subsequent year. Okay, so let's design or decide on the tables. We're going to use 3 tables. A table called student. Each row of student is going to contain the name and the student number, which is going to be a key field. There's going to be a table called unit, which is going to store the unit names and codes. There's going to be a table called enrollment. Now, enrollment is going to represent one attempt. So enrollment represents one attempt at a particular unit by a particular student in a particular year. Okay, so the year and the mark, for example, have to belong to the enrollment objects because they relate to a particular year and a particular they relate to a student's the outcome for one student in a particular year in a particular unit. Okay, so let's build them in the simplest way possible. Okay, here are some statements. This is obviously has none of that complexity of the example at the beginning. So create table student, that's the SQL that says I want to create a new table whose name is going to be student. Then there's an open bracket, and then there's a sequence of columns, and each column has a name and a type. So snum is going to be the student number, and I'm going to call that an integer. We'll see later whether that makes any sense, but we'll do that for the time being. Sname, the student's name, and that's going to be a field of type text. Now, a field of type text is used for storing character data. If you declare that a field is of type text, then there's no particular length assumed. So at the moment, any text information can be added, can be stored in the student name column. Okay, create table unit, that's a unit code, and that's going to be text, because unit codes are things like CITS1402. Okay, that's a sequence of characters and a sequence of letters and numbers. And the unit name is a text, so that might be so relational database management systems. So that would be a possible value for the unit name. Okay. The quotes, again, they're just delimiting. They're just telling us where this string starts and where it finishes. So the quotes aren't actually part of the value. They're just, it's just to allow us to refer to string objects when we might want to include spaces and things like that into the strings. Okay, create table enrollment. So the third table is called enrollment. It has 4 fields: a student number, a unit code, a year, and a mark. The end of each of these definitions, you have to put a semicolon as usual for SQL statements. Okay, so that's, there's no, now mentally, when I declared this, I was envisaging student number as being one of the student numbers from the student table, but I haven't actually enforced that yet. As far as SQL is concerned, the SNUM in the enrollment table is just another name. It's just another variable. There's no connection between the SNUM in the enrollment table and the SNUM in the student table. Okay, now I want to insert some values. Now this is not a DDL statement. This is a data manipulation language statement, but I can't show you I can't illustrate more without actually getting some data into the table. So the command to put a row into a table in SQL is insert into, then the name of the table, then the word values, and the actual values. One is going to be Amy's student number, and her name is going to be Amy. Okay, so the words in blue, insert, into, and values, are SQL keywords. They have to be there. If you want to enter a row into a table, you have to do it in this fashion. Type insert into, then the name of the table, whatever it is, then values, and then one value for each field. Okay, student has got 4 fields. They come in the order student number, student name. So when you put in a new row, you have to specify the values for those rows, one column at a time. In most implementations of SQL, the values have to be the correct type. So in other words, the implementation will actually check that this is actually a number, and will check that this is actually a string, some textual data. SQLite doesn't do that. SQLite treats types in a very idiosyncratic, strange fashion. I will explain in detail what SQLite does, but for your future use of like other SQL implementations, you can sort of assume that the values that are entered into the table must be the right type of thing. Okay, so let me just illustrate this again in the SQLite prompt. So in these 3 lines, I just created the table. You noticed I typed create table student, open bracket, and then I hit return. And then I got this, this thing here, which says command not finished, please enter more. And then eventually the command finished when I put the semicolon there. Okay, so that created a table called student. Okay, select star from student. That's just a quick way of showing me all of the rows in that table. Well, I haven't entered any rows yet, so there's no output. And indeed, SQL does not produce any output, but just gives me the next prompt to start working with. Okay, insert into student values 1 Amy. Now that does something, but it doesn't return any values. It's just an instruction. Put this row into this table. Okay. In order to check that it has actually done something, I'm going to again select star from student, and it shows me that yes, I have 1 row in there with the values 1 for the first column and Amy for the second column. If you don't like this way of this style of output where it just puts the value and then a vertical bar and then the next value and so on and so forth, you can change the vertical bar to be something that you prefer. You could change it to a space, for example, so you can more easily read the output. Okay, now I'm going to insert another row. So this time 2 and Bill. I'm going to do select star from student again, and now I've got 2 rows in there, Amy and Bill, and so on. You can see how you can just, by multiple insert statements, you can end up with a database full of rows. You've seen this already in the AFL.database. If you read the create AFL file, that contains all of the commands needed to create the tables and then fill them up with data. Okay, now I'm going to add some rows to unit. So same sort of deal. I've just got to state insert into, then the table I want these rows to go into, then the word values, and then the actual values. Here we have CITS1402, which is databases. Now I've deliberately just chosen short names for the names of the units here, just so I can put them on the screen for us to work with. In reality, of course, those names will be the full names of those units. You know, Introduction to Programming Principles with Python or whatever. And then here are some enrollments. Now, enrollments has got 4 columns. The first column is a student number. So this refers to student number 1. Now that's Amy. This is a unit code. So she did Math 1001 in 2018, and she scored 55. So in 2019, she followed that up with Math 1002 and got a 68. So Amy's going okay. She's passed her maths over 2 successive years. Bill, on the other hand, this is Bill, student number 2. When he took CITS1402 last year, he only got 30. Okay, so he probably didn't go to enough labs. So now he has to repeat the unit. How are we going to enter some data into the database when we don't know what the mark is yet because he hasn't taken the unit yet? Okay, there are 2 choices here. The first choice is we can insist that enrollment only contains completed units, and we can have a separate table for units that are in progress. The other way that we can do this is we can use a special value for the mark that means I don't know what this is yet. This is unknown or irrelevant. Okay, so there is such a value in SQL, and that's the value null. So null is a special field. It's a special keyword. So you have to type it in as NULL. It's not a string that has the value NULL. It's actually a keyword itself. And that just means don't know what the value is yet, undefined, unknown, or something like that. If you do enter something with a null value, then when you look at it using the SQLite prompt, you'll just get a blank space. That just means nothing there. Okay. We'll see later that there are special SQL commands for dealing with null as a value. So null is really being used quite proactively here, literally to mean this value is not yet known. Okay, let us go back to the data definition language and let's see if we can improve the tables by making them more robust to data entry errors. So the ideal here is that if someone enters something that's incorrect, maybe they've got a fat finger and they accidentally press the wrong key, then wherever possible, we want that error to be picked up immediately. So the whole point of this is to make your table sort of robust so that as many errors as possible are picked up before they sort of propagate through the database. Okay, so here's an additional feature of the DDL. After you've declared a variable to have a name and a type, you can also indicate that it is intended to be the primary key for this field. Okay, so what that means is that you've told SQL this field should be unique. There should only be one row at any other, throughout the entire life of this table, we should never have 2 rows of student with the same SNUM. So that's basically saying SNUM will uniquely determine a student. Okay, once we've told SQL that it is going to be a primary key, then SQL will enforce that for us throughout the lifetime of the table. So if somebody deliberately or accidentally tries to enter a row with a duplicated student num, then they will actually be prevented from doing so. So this is sort of the first layer of protection for your tables. We're only looking at small databases in the unit, of course, but when databases get very, very large, then one of the main things that you need to be able to rely on is that the data is consistent. You don't have different bits of data in different tables that contradict each other. So wherever you can, if you know that some constraint exists because of the business logic, then you should try to encode that into your tables, and then it will be enforced. So the key thing here is, if we tell SQL that snum is a key, then it will permanently prohibit any operation that would violate this property. So if you accidentally try to change a student number to be the same as an existing student number, it won't be allowed. If you try to enter a new student and you accidentally type the student number of a previously existing student, then it won't be allowed. So that just cuts off a whole range of silly errors before they even happen. Okay. So another sort of protective constraint that you can add to your tables is that you may decide, the database designer may decide, that a particular field should never be null. Okay. Earlier, we saw that the field mark, we allowed it to be null because we had a sensible use for the concept of a mark that is not yet known. However, there is no sensible use for a student with no name. So if the database designer decides, well, I really want, whenever a new student is created, I'm going to insist that they have a student number that is not already in the table and some name or other. Like, they've decided that if someone attempts to create a student with no name, then that really is an error and should be prohibited. We accomplish this by saying in the definition of the table that the student name field should be not null. It's hard to see yellow on yellow. Should be not null. Okay, and then that will just force that to be the case. If I try to enter a new student, student number 6, and I attempt to make their name null, then I will be prohibited from doing so. An error will be produced. So the DDL then is to do with constructing the table, the structure of the table, and telling SQL some things about the fields and their relationships that it must insist are always true. So the table is created not just as a list, not just as like a spreadsheet with a list of names, but actually as sort of a table that behaves sensibly. Okay? A table that prevents its contents from going bad in certain specific ways. Okay, we will later see more ways of preserving data integrity, and therefore they will be more features of the DDL, because all of these structural properties of the tables must be declared when the table is created. All of the stuff to do with actually inserting and reading data, that occurs after the table is created, and that's part of the data manipulation language, not part of the data definition language. Okay, alter table. One thing that's very frequent, particularly if you start developing a database from scratch, is that you start with some tables and then you suddenly realize you've forgotten something that was important, or you need to change the structure in some way. The SQL command to do such things is called alter table. Now what we're going to do now is we're going to alter table student. So this says some alteration is coming up. What alteration are we going to do? Well, we're going to add a column. And what column should we add? Well, we should add a column called email of type text. Okay, you'll notice that the syntax for SQL is sort of pretty weird. It's not really anything you could guess. It's just, you just have to type exactly the sort of special formula that it's expecting in order to make it work. If you type something that's incorrect, even if it's slightly incorrect, you'll get an error message that just says something like syntax error. So programming in SQL can be quite frustrating because it doesn't give you much help as to where the error arises. Anyway, the effect of this then would be to add a new column to the table. It'll be called email. It'll be of type text. If there are any rows in the table at the moment, so all of a sudden they get a new column added, well, what value will be put into that new column, the one that's just being created? So it's sort of like we've got student name, and so far we've just got 1 Amy, 2 Bill. Okay, suddenly I add a new column. Well, what values are going to be put in there? What will it do? What would be the sensible thing to do? Well, what would be sensible would be to say, well, we haven't really been told what this value is yet. It's just a new column, so it's just unknown. We don't know anything sensible to put in there, but we should put something in there because we've got a new column. So of course, that will be filled out with null values. If we then wanted to go through and alter those rows to put sensible email addresses in for those students, then we'll have to do that separately. As I said before, in other implementations of SQL, such as MySQL, you can do all sorts of additional fancy things. You can drop columns, you can add columns in a particular position in the list of columns. None of that stuff is crucial. You can do everything you need to do with SQLite. It's just sort of more convenient to have more commands. Okay, so just to summarize then, you can tell whether a statement is a DDL statement or a DML statement because the DDL statements all contain the actual word table. So if the word table appears, then that means it's an instruction that is to be done on the structure of the entire table. If you don't have a table command there, the word table there, then usually it's going to be a statement that is to be done to the rows of the table. Okay, so DDL contains the word table, affects the entire table structure. Everything else, data manipulation language, they're all the queries, and they create, read, update, and delete. Okay, suppose you decide, well, okay, that was sort of interesting about altering the table, but exactly what things are allowed in alter table? So this is a page, just a screenshot from the online documentation for SQLite, and it's the description of the alter table command. And it's sort of a bit weird because it's sort of like a flow chart almost. The way to interpret this is that if your statement starts here on the left-hand side next to alter and ends here, then it's a legal alter table statement. So first word must be alter, second word must be table. Okay, and now we have a choice. We can either take this under arrow like that, or we can go through the other pathway what does the other pathway do? The other pathway goes through here. So what that is saying is that you start with alter table, and then you have to give a table name, okay? Like we saw alter table student. Optionally, however, if you wish to, you can put after the alter table, but before the table name, you can put a schema name and a dot. Okay, so that's for situations where you have more than one database hanging around at a time, and you need to specify which table from which database. But we're only using one database at the moment. So alter table student, to come back here. Okay, what can I do? Well, I can add a column, and then a column definition is, well, column definition is as we saw before, and then that will take us out to the end. Okay, any different path through that little diagram gives you some alternative way of writing a alter table statement that will do something else. So, for example, we can go through in this fashion: alter table. I'll go through here. Table name, and then I could rename to new table name and come out of the end. So that tells me then that alter table unit rename to course would be a legal statement. So in other words, it shows me in a diagrammatic fashion all of the legal ways, all of the grammatical ways of constructing a statement that starts with alter table. I suggest that you familiarize yourself with these little diagrams, because that's really the only way you have of figuring out why you have a syntax error, if you do have a syntax error. For example, you might have sort of vaguely remembered how the rename worked, and you might try to do alter table rename course. You might not put the you might try and leave the 2 out. Well, when you work through the little diagram below, you'll see that after rename you have to have the word 2, and so that will show you that exactly where your statement is not working. Okay, well, that's all for the DDL today.